Okay, so today, let's talk about the section we're in. We're in section 10.2, it's the last day of it. We're going to be moving on to the next section, probably Thursday, I'll just put it that way. Section 10.2, I should say. 10.2 is based on arcs and angle measures, so arcs and central angles. So that's what we've been talking about the last few days in here. The goal is to do a couple examples. So the first part I want to talk about is the actual arcs. I want to do a couple examples of you finding, like the measure of an arc or stating like what type of arc it is. And then the next part, we'll talk about, central angles and all that good stuff. These go hand in hand. So the first two examples I'll kind of show you, you'll definitely see what I'm talking about here with this. Once we're through the few examples, I think I have like 3 problems with that picked out. Then the last style of problem is where you're finding actual arc length. And that was the part that we were kind of doing yesterday. I think we did, a Ferris wheel problem yesterday, something like that?
Yep.
We're going to continue with that concept today because that's what your homework problem is based on. And at the very end, we'll talk about that real life example I was saying yesterday. Did we get through the music stuff yesterday? Did I cover that all with you guys? Okay, perfect. So we'll talk about that, and that's kind of like the practical uses of this. That's what we'll end. This is going to go pretty quick, so I only got a select few that I want to go through, and they're pretty short and simple. But let's get to the first one here. I have them on the computer here, so let me throw it up to the board here. All right. So these first few, I guess I went in backwards order. These are central angles. The most part, I only have 2 of these picked out from the textbook here. They want you to find x. That's the central angle. Now, the big thing you need to know is what does a circle have to add up to be? 360. So the trick is, if you want to find x, there's 2 ways to kind of do it. If there's like pieces you need to add together, or if you need to subtract. So what I would do on this problem is take the 360, subtract the 130, figure out that answer, and then subtract the 60 right off the top of it. That's what I would do to figure out x. Now, if they had like multiple pieces, let me erase this here, because that's how you'd find that one. You subtract the 130 and the 60 and whatever that is on your calculator, that's your x. But if they have like some pieces in here, maybe these are, now I'm going to make up numbers because I haven't done the calculation. Let's say this is 20, 30, and they're not on a scale, and 70. The idea is that you can add these together to get that piece that's missing. And that could be another way you could do it. So don't feel like you always have to subtract. You could technically add to make whatever that piece is. And again, that was not accurate for the number. Questions on this first problem. Okay, now, second one I actually want you to try. So, because I do want to give you a chance to actually try them by yourself. So here you go. Second one here. Okay, I'd like you to try this one out. Actually put it in your notebook. I'm going to walk around there and I'm going to check. I want to see, can you figure out the value of x without saying it out loud or anything like that? So let's see what you come up with here. Now, just to give you a warning on this problem, this angle here is 35. This little piece. Okay, they're putting a little bubble in there, so you should know what the bubble means. But just this little wedge is 35. Okay, let's see if you can figure out the x. Again, if you need calculators, go grab one. I'm going to give you a little bit of time. I did want to give you a chance to try one by yourself today before we get into the next style of problems where we talk about all the arcs, all that good stuff. Once you think you have it, I'm going to walk around the room and kind of check out what you have. Try to write down your problem, your answer on your papers. Oh, nice. That's clever. Actually, that's really clever. You just blew my mind right there. It's actually really clever. I think you're onto something there. You're on $1 million idea. Actually, you know what you should do? You should get the one with the loops.
Oh, yeah.
Okay. All right. Anyone need more time? All right. Can somebody walk me through what was the answer for x?
150.
150. All right. So we got the 150 here. Now, why?
Because
Please.
when you add together the bubbles,
Yep.
it's 70.
Okay, good. Because you're adding 35 and 35, which is 70. Good.
So then put together 140 and 70, and that's 210.
70, which is 210.
And then to get 360, it's 150 plus 210.
Yeah. So you could do it this way, where you subtract, or you got to figure out what you want to add to the 210 to make 360. That's the idea. So either way you do it, it's got to be 150. That's got to be your number. Now, the most common mistake people make, especially on the homework when you start, is not recognizing what they're telling you here. Not like, look at this problem going, okay, this is 35 and this little bubble means the same. Some people like automatically think that the whole thing here is 35. They're putting in that one little wedge piece on purpose. If the whole thing was 35, they would probably write it like this. And they wouldn't bother putting like the mark through the middle of it. So just be kind of aware of that. It was just one of the problems I saw in the book. I'm not assigning that one, but it was one in the book where they had a couple pictures that were really close to this one, so I just kind of pulled it out. Thought that it would definitely be helpful for what we need. Okay, so those are central angles. They're pretty straightforward, pretty easy. Second style problem now. Let me flip to the next one here. Okay. All right, next one. Now on this particular problem, now they're giving me a bunch of pictures. They have a couple diameters on this picture. I believe in the instructions they say HK is a diameter and IG is a diameter. So they're going straight through. So HK and IJ or IG, I should say, are diameters. And they ask for certain pieces. Like for instance, they want you to find the measure of arc IHJ. And they use 3 letters. I'm not even sure if that's correct notation, I guess, for this one. IHJ. Yeah, I guess it is. They went the long way around. But again, 3 letters. Typically, when they show you a 3-letter system that's a major arc, they want a large number. Okay. So IHJ. Now, why I brought this one up? This one is probably the more difficult problem out of the ones I saw in the book, because they want you to go from here, H, all the way to J. There's 2 ways to do this problem. One way is easy, one way is definitely not. The easiest way that I saw this when I first looked at it was taking 360 and subtract the 90. Because this angle's 90. And this little box. So going all the way around, because that's what it means. When they have a little n, that means they want the angle on the inside, the central angle. So when you actually subtract that, what do you get? 270? Okay. All right, perfect. Now, second way. And this is probably the more difficult way of doing this problem. This is the one way if like you weren't thinking about the whole 90 situation and you were trying to add pieces together, you'd actually have to transfer this 59 over to here, because it can go vertical, straight across. And this angle in here should make 90. So you could figure out this missing piece, which I don't know why you would want to, but you could figure out the missing piece, and you could figure out this piece over here, H to G, because this whole thing is a diameter, so this has to add up to be 180. So in theory, this would have to be like a 121. So you could add those pieces together. I don't know why you'd ever want to do this, but you could. Question?
So I'm confused. What are we trying to find?
You're trying to find the measure of IHJ. So that's the 270 that I just showed you. But the idea is that some people like won't see that you can just take 360 and subtract the 90. They would try to add like the individual pieces together. Okay, they're trying to go from I all the way to J and trying to find the angle on the inside, because that's what the little M out front means.
Which angle?
The central angle. I'm talking about like this. Yeah. So yeah, because that's what it means when they put a little M. It means that central angle, the angle in the middle of the picture, like all the wedges added up. I know that seems like overly difficult the way I'm doing it the second way, But some people see that, like that's the only, they have like the tunnel vision going, and that's all I can see. Like, I have to add pieces together. So you just have to think about, okay, what are the diameters? Things have to add up to be 180, certain things are 90s, and you can find pieces. But just kind of think about outside the box. Sometimes you can just subtract, and it's done in like one step. Most of the problems, I feel like when you're doing these problems, there's always one simple way to do it. There's a difficult way, but there's always an easy way. Just for, you know, if you just get out of that tunnel vision, that you don't always have to add or always have to subtract. Okay, so what I'd like you to do is try one out by yourself. So let's try. I want the central angle for JK. I want that one. So I want you to try this one by yourself. I want JK on that picture, like the actual measure of it. So this is the angle on the inside. So if you want to know where that's at, right there. That's what I want. I want to see if you can figure it out. I want to at least give you a chance to try one by yourself before we move on to the next type.
I have that one as well.
That's not what I can.
We're not trying to find
Yeah, either way, I did
Oh.
pick a couple different ones.
I typed in the wrong.
Okay, I was gonna say like that. I did it like 2 different ways. I didn't get that. Okay, that's it. Okay. Adam, whatever you do, don't write your answers like that on my paper. Jeez, I used this whole paper. Okay. All right. What do we get?
31.
31. All right. Now let's talk about. There's a couple different ways you can do it. But this is the angle I was looking at for this angle. That is JK. Because again, when they use the 2 letters, that's a minor arc. But the M out front means they want the actual measure in the central of the angle. Now, how do we figure out 31? So,
Transfer the 59.
okay. Transfer the 59 across. Hit 59 here.
80 make 90.
Okay. Yeah, because these 2 angles, when you transfer the 59 across, these 2 angles should make 90. How I know that? They're right next to a 90, and this is a diameter from the instructions. So the only way that this could be a diameter, if it adds up to 180, is if these are both 90s. So yeah, so taking the 90 and subtracting the 59, because that was a vertical angle. So now the other way that I could definitely see people doing it, taking 180, subtracting the 90 and the 59, getting that, instead of just going 90 minus 59. Seeing like the actual parts involved. But either way, it's the same answer. It's the same work that you're doing. All right, questions, comments about how we get 31? Okay, all right, perfect. Let's move on. All right, so next one here. Okay, all right. So on this particular problem, they want certain parts, and they want you to first identify, is it a major, minor arc, and then figure out that measure of the angle. So it's kind of like the last one, but it was a secondary part where it said state the type of arc, the classification of the arc. So one of the questions it asked for, it wants the arc PQR, and it wants to know what type of arc it is. And then once you have that, then it wants the measure of it. Okay, on this particular problem, I believe they say that QS is a diameter, so that's the instructions. So QS is straight across. So PQR, so that's this one right here. Now, it may be drawn right, it may be drawn wrong, because maybe they shouldn't write it like that. We can talk about it. They're just giving you 3 letters to know which direction you're going for it. We'll talk about it and we'll see, is it even written correctly? Because sometimes the book, they do this thing where they write 3 letters even though they meant to write 2 if it's a minor. But if it is major, we'll talk about it. All right. So again, when you have this problem, What I would do first, I would probably find this wedge piece here before you start. The reason why, you know that QS is a diameter, so this means this side should have to be 180, that side should have to be 180. That will help you find like the missing piece, and it will help you find this angle here. This angle, which and most people know what this angle is going to be right there, but the smaller one is not. So if you take 180 and you subtract the 72 and you subtract the 75, we're left with this angle right here, which is 33. Okay, so that's kind of a small angle. Now, what's this angle right next to?
90.
Yeah, that should be 90 because it's right next to the other one, and it was a diameter. So now that we have that, now you can add the two pieces together. These two. You can add the two pieces to figure out the whole thing. Now, there's another way to do this, which I said there's always an easy way to do it if you didn't like that method of me doing this. But to get the measure, you would add the 90 and the 33. That's arc addition. It's the postulate we have. You can add the two arcs together. And what do you get, 123? Okay. Now, is that a major or minor arc? Minor. So in fact, this is a minor arc. So really, they didn't even need to write 3 letters. They could have just wrote PR, and it would have meant the same thing. Because minor arcs are anything less than 180. That was the question.
Yep.
Yeah, anything less than 180 is a minor arc. So they only have to use 2. But the book tend to uses 3 when the picture's like overly complicated, and they're trying to get you to really figure out which way they're trying to draw it. Now, the easy way of doing this problem, by the way, easy way, is not even having to figure out the 33 and the 90. It's actually just taking 360 and subtracting these 3 parts off. That's all you have to do. So take full 360, subtract 90, subtract 75, and subtract 72, because that will leave you with these 2 pieces by themselves, like added together. So if you did that, it will just automatically give you the 123. You don't have to like add the 2 pieces separately. So that's kind of, there's always an easy way to do it and always kind of a more challenging way. I kind of did the challenging way. The reason being that why I did this way is that some of the problems, like they give you a picture like that, but then they ask you a series of questions about that picture. But this one is pretty close to what I think the first few problems are going to be. They ask you like the classification, they ask you, find the measure of it, even though that's in the instructions, and they give you a couple of things to look at. All right, questions. All right, last problem of the day. Last problem that I want to get to before we get to my real life problem that I want to talk about yesterday. And this is my last problem. This is like the Ferris wheel problem we did yesterday. This is a lot like what your problem is going to be in the very end of your homework. I think it's the last 5 problems you have. They ask you to actually find an arc length. So that's this part right here. Find the arc length on your actual circle. So to do this problem, you have to use this formula. S equals R theta. That formula is used when you have a radius of a circle, which they did give me. They gave me my radius is 2 feet. They did give me an angle on the inside, the central angle, and now you can find the arc. So like maybe the arc they want you to find is, I think on the instructions they actually say find JK. They want you to find that arc there. That's how long they want you to. And again, the pictures, they'll have a series of pictures and they'll ask you to find certain arcs. But you have your radius, you have your angle, you can plug it in. So here's how you do it. Take your 2 feet and you're going to multiply it on your angle, because that's what theta is. Now theta, you have to convert it, because it can't be just 30 degrees. You have to convert it to radians. So the trick was you have to take it times pi, divide by 180 on your calculator. Everybody has a pi button, but if you don't, just type in 3.14 when you take it times pi. You'll be fine. You'll be in the ballpark anyway. But when you actually do this, I'm going to type this in just so you can see this. So 2 times 30 times pi divided by 180 is 1.04. And that's in terms of feet, because that's what this S stands for. It means arc length. So that's the distance we just traveled along that arc. So it was 1.04 feet. And does it make sense? Yeah, I mean, this is 2 feet. So this kind of looks like about a foot. So if you want to compare them. They're going to be somewhat drawn to scale, which I was actually kind of surprised about. Because I kind of looked at them earlier, trying to see what you needed to do for it. Now, why I brought this problem up, this is the last one, because we were talking about this yesterday. This problem is going to be a little bit different on your homework. they're going to give you a picture of a Ferris wheel. They're going to say find the central angles. They'll have a bunch of things in the picture, and they ask you for certain arcs. But the part that I want you to follow, because this is where I'm going to modify it, I want you to find the actual arc length. They don't give you the diameter or the radius, but I'm going to give you it. So anytime you're in your book and you're on these it's like the last 5 problems, and they have the Ferris wheel problem. Okay, the Ferris wheel problem. They give you all these angles in here, and they ask you to find the central angles. I want you to find the arc as well for that problem, whatever arc they're talking about, whatever central angle. So if this is a 40-degree angle, what I want you to use for that problem today, I want you to use for the radius of your Ferris wheel, I want you to use 24 feet. So this is the number you need to have for your homework today. 24 feet for the radius of that Ferris wheel when you get to that problem. It's the last few problems. And what you need to use with that is you need to do this. They're going to give you the central angle. You have the 24 feet. Now you can find the arc you're actually passing through. So that's the slight modification I'm making to your homework. Yeah, so radius is 24 feet for that Ferris wheel problem. Trust me, you'll know it when you get there. You'll know it when you see it. And I want you to find the arc, the distance along the arc path. Okay. All right, last thing here today is to talk about the real life problem that I hinted at yesterday. I think I was like, we just got done with the real Ferris wheel problem yesterday in class, and I hinted at that there was another real life based problem I wanted to talk about. And it was something that I was trying to think of, because the Ferris wheel problem isn't realistic. You're not going to be on a Ferris wheel every single day. It's not a calculation you would use that would be useful. So I was trying to think of things that in your life that impact you guys. Things that you use almost every day or potentially every day that you wouldn't think about necessarily, but uses this type of math. And so the idea that I thought about yesterday was, and it's not far-fetched. I mean, it's a realistic type of problem. I'm going to leave that up there. Let me get rid of the pictures here. All right. So the problem I was thinking of was music. It's music. And what I mean by music is that music has actually evolved quite a bit over 30 years. And what I'm talking about is there's an LP record that came out, what is that, the 70s, 80s, something like that, where LPs were really big. Like the music quality on an LP record is actually super accurate. So there's 3 types of LP records. These are the 3, okay? And what I mean by an LP record is that it's basically just a disc platter that has grooves on the actual platter itself. And what you do is on a turntable, you put a needle on it, and in the actual grooves there's like little waves, and the needle interprets the music itself. Well, the idea is that these 3 objects, you can still buy them, by the way. You can buy them in Best Buy and Target and stuff, LP records. In Best Buy, they're backed by the TV department. Target, they're between the TVs and movies. They're super accurate sounding. Some people actually prefer the records themselves as opposed to like CDs or anything like that. But the records themselves had different speeds that they spin at. So like for instance, a 78 means 78 RPM record. It's revolutions per minute. So every minute that thing spins 78 times. That record had a playing time of about 5 minutes. The platter itself was like 10 inches in width. A 45 record obviously has 45 RPM, but this one had about a 20-minute playing time. So, in the music industry, they used a 78 for like a single, like if an artist released a single or maybe a 2-track album, like an early release. They used a full album would be a 45. The Beatles did that a lot when the Beatles were releasing. They could get about 7-8 songs on one of those. And then used a 33, which is like a 12-inch platter, and those could play for about 35 minutes. And so, and eventually they used both sides, so you could fit double-sided, so you could actually listen to music when you flipped it over and keep going. So those are like double albums, the White Album and stuff they released. But they're super accurate. Now, why I brought this up is because it's using this type of math that it's using revolutions per minute, and artists were trying to figure out, how much data they could fit on a platter, because of the actual like circumference was a big deal. Like, knowing how many songs you could fit on the platter by how long your song was, because the needle slowly moves from the outside inside. That's actually how a CD player works, and that's probably more prevalent to you guys, or at least your parents probably. CDs anyway. You go to the store, buy a CD. A CD is just a version of a record. It's just smaller. Here's my terrible CD. I use it as a coaster. But CDs have smaller radii, right? A CD itself has a 2.5-inch radius. So 2.5-inch radius. Now the difference between a record and a CD spins at 500 RPMs.
Jeez.
And it's digital. So if you actually looked at the inside of a CD player, they just have this little, it's an eye, it's just a glass eye that goes back and forth between tracks. So it's just like a record. On a record on a turntable, you just pick up the needle, you put it at the end, and it kind of works its way to the inside. But on a CD, the glass eye just moves and finds your track and plays, and it just works its way inside out, or outside in. And so that when you click the next key, the eye instantly moves. It's not like a record where you have to pick it up and actually place it. But if you actually think about distance, this thing is traveling. It's traveling way further than a record. So like, imagine, this is a terrible example, but imagine that you had a sticker on the outside of your record, and you want to know how far does it travel in a minute. Well, the actual record itself, let's say we're using a 33, so a 12-inch record. Okay. So if you had a 12-inch record and it was spinning, let's go 78 RPMs. So you're going around 78 times, revolutions per minute. Well, that means you're doing 78 360s. Doing 78 360s on a 12-inch platter. So this angle's huge. And in fact, that little sticker went a long way. It went incredibly far. So just to give you an idea, 78 RPM, so 78 full revolutions times 360 is 28,000 degrees. So you take that times pi, divide by 180, and then you take it times the radius. You just traveled, if you went 78 RPMs for 1 minute, it spun for 1 minute, so perfectly 78 RPMs. It did this many inches in 1 minute. Which if you divide by 12, that's 490 feet that a sticker traveled in 1 minute onto that. Can you imagine a CD though? CD is going way faster, 500 RPMs. Now why I bring this up is that a lot of you guys don't even use CDs anymore unless you take them in your car, but most cars can now handle MP3s and stuff. Well, MP3 still, the idea of like a digital music, MP3 still has the idea of like it's a non-movable part. It's just a file. It's lossless quality, so you can have any quality of music you want on an MP3. But the weird thing about an MP3 is that you still have to worry about the hard drive that your computer has, right? So the hard drive in your computer that actually stores all the MP3s. There was different size of hard drives in there. There was a 5400 RPM drive. Those are like usually laptops and stuff, and then there was a 7200 RPM drive. Those were kind of the more faster desktop computers, and then now we're moving into flash memory, and I think that's what your Chromebooks use, your iPhones. There's no actual like physical hard drive in there. It's just a little flash storage. It's kind of like your flash drives that you plug into the side of a computer to store files on. It's flash memory. There's no movable parts. So there's no like spinning drives. Like these old hard drives, the old school hard drives, they're like actual disc platters, like this, but they're way smaller. And they spin, but there's multiple platters stacked on top of each other, and there's multiple needles like collecting them all. So it could write to data. And why they're insanely slow is because this RPM is not slow, but why it's slow, it has to find an open space and then it can start writing to it. That takes forever. Right, it's trying to figure out, okay, where's the open space, and then is there enough room? Yeah, and then it'll start writing. It takes a while to transfer files from one computer to another. Flash memory is almost instant. That's why you can transfer huge files from one computer to another if you use flash memory, like a flash drive. It's almost instant, because it just knows instantly there's a big block of non-used parts, and it'll just throw the files in where it needs to. But a lot of people don't think about this. It's using this math we're talking about. I'm not joking. It's using the concept of, of circles to actually store data. Now, obviously, computers are evolving, so they're going to different types of memory. We're trying to get away from circles. I think one of the most recent things that that science has pumped out is that there's a way to imprint data on glass. So that'll be probably the next idea that they're going to do. Instead of like CDs and stuff, that they can store terabytes, like not gigs, not like hundreds of gigs, thousands of gigabytes worth of data on like a little glass circle. So I think what they did is to prove their point. The scientist was holding up it looked like a contact lens, and they actually printed the entire Bible on one side of it, like every page of the Bible, right, on one side, because they could get the nanotechnology of the laser itself actually printed it across the lens of the actual contact lens. And so then they proved that they could do multiple layers, so they could go behind it and print more data. And so so that's like the next kind of frontier that they're going to probably move to. And the best part about glass is it doesn't deteriorate like plastic does. Plastic deteriorates over a couple hundred years, but glass doesn't. It takes like thousands of years to deteriorate. So your data wouldn't be correct. So, but it was just one of those things. Like when I hear about that type of stuff, I like it just because I know the math that's involved. But a lot of the stuff, like you don't even realize that things you use every day had something to do with this. So especially music, I thought that was kind of a cool concept. But anyways, digressing. All right, here we go. Homework today. This homework assignment that I'm going to give you is due Thursday. So keep that in mind. Even if we don't have school tomorrow, you might want to take your book home tonight. Just saying, take your book home tonight. I'm not expecting school tomorrow. So here we go. And on the Ferris wheel problem, make sure that you're using 24 feet. All right, here we go. Here's your. All right, we're on page 710. Here we go. We're doing 12 through 21 and 26 through 30. And these problems right here, these are the ones where you have to use 24 feet for the Ferris wheel. So a 24-foot radius for the Ferris wheel, and you have to find the actual distance. So if they ask for, like, let's say number 26 says, hey, find the length from L to G on the Ferris wheel, and they might have it labeled like L and G. Well, you have to use 24 feet, maybe this is L and this is G. So they'll give you this angle, and you have to figure out the distance you just traveled. So use that S equals R theta. All right, but there you go. I nearly marked every single part of me with that stupid marker drop. Jeez.